squares. So the last type of factoring that we're going to look at in this quadratic expressions unit is difference of squares. So what do you need to know? So you need to know that a square number is the result of another number multiplied by itself. For instance, 9 is a square since it is a result of 3 times 3. So some other examples of squares include 1, 1 times 1, 4, 2 times 2, 16, 4 times 4, 25, 5 times 5, 36, 6 times 6, x squared, x times x, and so on. So the opposite of a square is a square root. For example, the square root of 25 is 5. So recall that the special product of a plus b times a minus b was equal to a squared minus b squared. So this is what we call the difference of squares. So right here, this a squared minus b squared is the difference of squares. So it's the product of two binomials. Remember, a binomial is an expression that has two terms. A plus b is a binomial and a minus b is a binomial that share identical terms. So they both have an a term at the beginning. They both have a b term at the end, but they have opposite signs. So one is an addition sign, one's a subtraction sign. And the result is what we call the difference of squares. And it's called a difference of squares because the first term and the last term in the binomial are perfect squares. So a squared is a times a, and b squared is b times b. So sometimes these are both letters, sometimes they are a combination of letters and numbers. We're going to take a look at some examples and how you can spot a difference of squares as you're going throughout your course. So how do we know that an expression is a difference of squares? Well, we know that the first term is a perfect square. So the root of x squared is x. So that's a perfect square. The root of 16 is 4. So 4 times 4 gives me 16. So that's a perfect square. And it's always a subtraction sign. So always minus in between those two. If this was a plus sign in between, this would not be a difference of squares. So the word difference means subtraction. So let that be the key to help you remember. So what about 4y squared minus 49? Is this a difference of squares? Well, let's see. What is the root of 4y squared? Well, the square root of 4 is 2, and the square root of y squared is y, so that's a perfect square. And what is the square root of 49? Well, that's 7. 7 times 7 is 49. So that's a perfect square, and it has a subtraction sign in between, so it's always a subtraction. So these are both difference of squares, so that's important to remember. So the first term is a perfect square, the second term is a perfect square, and there's always a subtraction sign in the middle. So how do we factor a difference of squares? Well, we have to remember about difference of squares in terms of foiling, factoring trinomials, and so on. So when expanding a sum and a difference together, your result is going to be a difference of squares. So remember, when expanding, you can use FOIL or the formula a plus b times a minus b equals a squared minus b squared. So we're always looking for the number that the first term, the square root of the first term, the square root of the second term, and so on. So let's just, for just a recap, let's practice foiling out or using our formula for this first example. So x plus 4 times x minus 4. So this is, the binomials are exactly the same except one is addition and one is subtraction. So this becomes the square of the first term, so x squared. and the square of the second term, so 4 squared is 16, and a subtraction sign in between. So this expands to x squared minus 16. And x squared minus 16 is a difference of squares because x squared is a perfect square and 16 is a perfect square. So when we factor this, we can recognize a difference of squares, and it's easy to reverse that process by finding the factors. So for example, if we were to factor x squared minus 49, this is a binomial where the terms are both perfect squares separated by a subtraction sign. So it becomes, in my brackets, I'm going to find the square root of my first term. So x squared, the square root of x squared is x. So that goes in the beginning of each of my brackets. One is going to be a positive, one's going to be a negative. It doesn't matter which order you put it in. And what is the square root of 49? Well, that's 7. So 7 times 7 is 49. So we want to find the square root of both terms, and then put the square root of the first term at the beginning of each bracket, put the square root of the last term at the end of each bracket, and they each get a different sign. Okay, so think of the number that when multiplied by itself will equal that term, place those in the brackets, opposite operations. Okay. You could check this by reversing the process, so by foiling it out. We've done a lot of that in this unit, so I trust that you can do that on your own, and we'll keep going. So we have to notice that the signs between the factors, so one will always be an addition, the other will always be a subtraction. So keep that in mind as well. So let's go through a couple of more examples. So we have 9x squared minus 64. So we need to find the square root of the first term. The square root of 9 is 3. The square root of x squared is x. So 3x goes at the beginning of each of my brackets. Gosh. There we go. One's an addition sign, one's a subtraction sign, and the square root of 64 is 8. So 8 goes at the end of each bracket. The next example, so truly this is the easiest of the factoring that you will probably have to do. So enjoy these easy questions while they last. We already know that the square root of 9x squared is 3x from our first example here, so we can write in our 3x at the beginning of each of our brackets. The square root of 36 is 6, so 6 goes at the end of each bracket. One's a plus sign, one's a minus sign. You're done. And the last example that we're going to take a look at, we have x squared minus 121. So we're writing two brackets. The square root of x squared is x, so that goes at the front of each bracket. The square root of 121 is 11. That goes at the end of each bracket. One's a plus sign, one's a minus sign. You're done. So I hope that helps you find the factoring of difference of squares. It truly is the easiest of our factoring, in my opinion. Feel free to disagree with me. I would love to hear your opinions. If you have any questions at all, please put them in the discussion post in the virtual learning environment or send me an email.